I'm Walker Henderson, and I'm going to talk about latency and synchronization in web audio. So for a while now, I've been working on this app called Resonator. And what it is it's kind of all the stuff that you can do with a basic loop pedal, but in the browser. And it works on most desktop and mobile browsers. And basically the biggest problem that I've had to solve when building this is synchronizing the loops that are played back by the looper with the performer. So if you've ever done live looping, the synchronization is super important. If we have a loop that's out of sync with the performer, it just sounds really bad. And if things get out of sync and we keep adding loops, then that delay kind of adds up over time and everything sounds super loose and awkward. And so I've spent a lot of time working on this and trying to solve this problem. And so I'm hoping to share some of that so that you don't have to spend all that time. And we can basically implement apps that have musical synchronization between the browser and the real world. So to kind of like frame what I'm talking about, let's look at this specific case that we have to implement for a looper. So to start performing with a looper, you hit a button, and then you record some audio, and then you hit a button again, and at that point, we stop the recording, and we start playing back whatever we recorded. And this just then continues to loop indefinitely. And the key piece of this is that the audio that we're playing back is aligned with our initial performance. Like it's on beat with what was already sort of initially performed. And the naive approach to implementing this is really straightforward. We just start recording when they press the button, stop recording when they press the button, and then just like start playing the audio at that point as well. The problem is this doesn't work. It doesn't work at all. You're going to end up with this big gap between when they press the button the second time and when you actually hear the audio, and what we recorded is not going to be quite right. Like it's going to miss like the end of the initial performance. And the reason for this is that there's latency. There's a bunch of different places where there's latency in this like chain of interaction and signal processing. And so we need to cancel out these latencies between the real world, the browser's main thread, and the actual audio system. And we can minimize these latencies. Like there's a lot we can do to make these latencies really small, but barring crazy real-time operating systems and stuff, they're basically unavoidable and kind of inherent to the hardware and software that we use. So with that in mind, let's kind of break down each of these latencies that we encounter when we're trying to implement something like this. So the first sort of latency that we have to deal with is what I'm calling UI latency. That might be the technical term for it. I don't know. So in this case, it's the time between when a button is pressed and when we have that corresponding event handler on the main thread call whatever callback you set for it. So this second timeline here kind of represents the main thread and the DOM events that we receive when there are interactions. We also have to deal with audio input latency. So that's the delay between when some audio is produced in the real world and when that sound is actually realized in our audio context. And so this new timeline, it kind of roughly represents the audio stream that's processed in the audio context. And this new orange bar is the audio that we've recorded from that real world one. And finally, we have to deal with output latency, and that's going to be the delay between when we schedule a sound to occur and the corresponding time that that sound is actually produced by a speaker or headphones. And this latency is probably pretty familiar to all of you who have implemented like a synthesizer in web audio. You know, when you press a button, it takes a while for you to actually hear the result of that. So this new blue bar kind of represents like the loop that we recorded being output by a buffer source node. So almost immediately we kind of run into a problem, which is we don't actually know what these latencies are. Like we need actual values for these latencies to do anything about them. So can we get them through the API? Not yet, is the short answer. There's output latency, which is part of the spec, and that's great for output latency. Again, doesn't have browser support at the moment. One thing that we can do is we can actually measure these latencies ourselves, or at least get kind of combinations of the latency. So this is kind of a pretty crazy like timeline of things that we can do where we have button presses and we're recording the sound of that button being pressed, like the actual physical noise of it, and then outputting a sound after that button press. And if we measure the sort of time difference between each of these events, we can get some approximations for the latencies that we have to deal with. One thing that we have to consider, though, is that these latencies change a lot between devices, and even within the same device. If you, say, have a phone and you're using the built-in headset, then that's going to be way different levels of latency than if you use the headphone jack. And so I kind of built a tool to measure these things, and I'll open source it at some point. But basically, we need to handle these latencies on like a device-by-device case. So another thing that I've kind of looked into is like because these latencies differ, we need to actually have a way to measure them. And when you're using the onboard speaker and microphone, it's pretty easy. You just kind of output from the speaker, receive it from the microphone. And people at Google came up with this solution for doing the same thing with the headphone jack, and they had this, they call it the Rick-O-Rang audio loopback dongle, and I have no idea why it's called that. But the thing about it is it doesn't actually take any sort of additional audio input. So one thing I kind of mess around with is adding like a piezo buzzer element to this. And that way we can actually use that as like a contact microphone, and if we like hit a button with that microphone, we can get the sound of the button press and use that as part of our measurements. One thing I'll say as a disclaimer is I'm not an electrical engineer, so if you use this schematic and your phone blows up, I'm not responsible. So now that we actually have these latency values or estimations for them, we need to apply some offsets to correct for them. So for this first button press, we want to start the recording at the time of the button press plus the audio input latency and minus the UI latency. So a key thing to point out here is that our UI latency might actually be larger than the audio input latency. So we saw that earlier on the slide with like the different measurements. And what that means is that from the perspective of the main thread, we might actually have to start recording at some point in the past. So that's something we'll have to handle. One thing I've been kind of glossing over is the fact that we actually need to convert the time stamp that we get for this button press from a performance.now time to an audio context time, because they're two separate timelines. And the best way to do that right now is you get a timestamp using get output timestamp. And actually the spec has an example kind of function that they just give to convert between performance.now coordinates and current time coordinates. Again, browser support is not great. And kind of as a fallback, we can just use current time. But you know, it's a little less accurate. So now we have to deal with all the stuff that we do when the second button press happens. So when they stop recording and want to start playing back the loop. So we stop recording at kind of the button press, plus the input latency minus the output latency, and then for like playing back the audio, we start it at that timestamp minus the output latency minus the UI latency. And one sort of key thing to point out here is that we basically always start playing the audio in the past relative to that button event on the main thread. So again, that's another thing we need to actually handle when we're doing all this timing. So with all that, we kind of have this list of requirements that we need for our audio system. We need to be able to start and stop things at very specific times. For recording, we need to be able to play recorded audio before we're done recording the entire thing. And for playback, we need to actually start playback at some time in the past. Oh yeah, and we also need to be able to start recording in the past as well. So the solution that I currently have, that's not perfect, but achieves all of these things, is this. So we basically have either a worklet node or a script processor node, and we just take chunks of audio from that node and give it a timestamp and send it off to a worker. And that worker is just going to keep track of all those chunks, and it's going to hang on to about a second or so of audio. And that way, if we want to start a recording in the past, we have a little bit of margin there, where up to a second in the past, we have that audio stored. So once a recording is started, we kind of hang on to all the chunks that are going to be a part of that recording. And at the same time we're sending all these chunks off to the worker, we also create a short temporary audio buffer. And that's on the main thread. And what we use that for is that initial moment when they hit stop, because we want to start playback immediately, but we still need to keep recording for a little bit. So this gives us, again, like a little bit of margin. And that's because what happens is once we finish the recording, the worker has all of these chunks, and then it assembles all of them into one giant buffer and throws it back to the main thread. And at that point, we then swap out the temporary buffer for this combined buffer. So the playback system needs to deal with all this too. So one thing that I think is kind of interesting about this is it's kind of inspired by React in that it has sort of a declarative-ish API in the sense that it has a bunch of props, including the start and stop times of the actual, the start and stop times as well as the audio buffer that we currently want to play. And any update to any of these props is valid. So if we want to change the start and stop times or change the buffer, then we just swap out these props, and our loop playback system will just automatically handle all of those changes. So an example is if we want to swap out those buffers, we can just do that, and it'll choose a time sometime in the future to swap them out. And it also allows for a start time to be set in the past, and it'll figure out what offset it needs to do to play the buffer at the right time. So a cool property of these systems is that they don't have any logic that cares about latency They only care about when audio should be recorded and when it should be played back. They also don't care about what the current time is. So you can set these times for start and stop in the past or the present or the future, and it should just handle it gracefully. And worst comes to worst, maybe we're like missing a piece of audio in the recording. But these are like really rare cases where generally the user shouldn't expect to like record audio. I'm thinking like if they start up the app and immediately hit the record button or something. So one thing that's great is if we have a recording system that's this flexible, then we can make some really cool features. So let me give you an example of a problem that I've had way more often than I really should. So I'll be recording a melody, and that melody has a pickup, so a note that's kind of stuck right before the first full measure of the melody. And what I'll do is I'll look at this melody and I'll think, I'll set my punch in, punch out points to the start of that measure and the end of that measure. And then when I go to record it, it's missing that first note. And the perfect take that I just recorded is totally useless, and I throw my computer out the window in anguish. Since our recording system is already sort of hanging on to some extra audio that's in the past, what if it just hung on to that for an even longer time? And what if it took that audio and appended it to every recording that we do? If we did that, then we'd have this little extra sort of grace audio that we could sort of edit our audio after the fact and fix that problem. Another cool thing that we can do is what I'm calling button press fudging. So say we're in our looper and we have some loop that's currently playing, and we want to start recording a new loop. And we want the alignment of that recording to be sort of perfectly aligned with the start of the loop. But because we have really poor rhythm, we press that button way too late. Again, if we're recording all of this audio that's in the past, and we can kind of infer that when they press that button, they actually meant to press it at the start of the new loop, then we can just kind of say that that's what happened and fill in the audio. So in conclusion, basically if we want audio to sync up with the real world, we need to correct for latency. We can kind of think about these timelines and figure out what offsets we need to apply to each of the basically each of the events, each of the sort of start playback, start recording, stop playback, stop recording, each of those events. We can actually get measurements for all of these offsets, and we need really flexible recording systems to actually do that. But if we have a really flexible recording system, then we can do all sorts of cool stuff. So yeah. Thank you for listening. You can find me at Bricklanos, and Resonator, the app I built, is at resonator.app. Thanks.